Hello. Today we're going to talk about encoding and forgetting from episodic memory, the ability to retrieve things from our past experiences. Now, when you encode something into episodic memory, there are things you can do to have better encoding, or there are things you can do to have poorer encoding, and that's what we're going to look at. For better encoding, we have better encoding, we have depth of processing, organization, imagery, and we'll talk about some really good encoding, the so-called flashbulb memory. Now, depth of processing was talked about in the early 70s by Fergus Craik and Robert Lockhart. And it was sort of a very important way of thinking about how we encode things into long-term memory, into episodic memory. They, for example, talked about 3 different levels of processing. You have, does a word contain an E, a very superficial processing of the word, sort of a phonemic comparison. Does the word rhyme with pale? A little bit deeper, but again, sort of superficial. Or is the word a living thing, where you have to actually encode the meaning of the item very deeply in order to be able to answer that question? So we have shallow processing all the way to deep processing. And their argument was that the deeper the processing, the better the memory is going to be. So you simply do an experiment where you have some items that you ask these superficial questions to. Does a word contain an E? Middle level processing, does a word rhyme with pale? Or deep processing, is the word a living thing? And what they found was that recall and recognition of those items depended upon what kind of processing was engaged in. The percent recognized, for example, was much higher if you had the category classification as a living thing. The rhyme was less, and the sort of very structural task, very shallow task of just saying does the word have an E in it, led to the worst performance. So the nature of how deep the processing was determines how much is actually remembered in a later memory task. You saw the same words, but if you process them in a deep way, you remember them better. Even though it's not the time that you took. With this task that I just described, it did take longer to answer the living thing versus does the word contain an E. But I can make the structural task very difficult, takes a very long time to do, and make the semantic task easy, and you still get exactly the same effect. The levels of processing effect, the depth of processing effect. The more semantic the processing, the better you're going to remember the item. The next, in addition to depth of processing, is organization. And these experiments have been done over the years many, many times. If you group the items together into meaningful categories or chunks, you're going to remember them better. For example, I might present words that come from different categories, like 6 words from 5 different categories: vegetables, vehicles, animals, kinds of clothing, vehicles. I present those different words and have them randomly in the list. The interesting thing is when you recall them, the person recalling those items will, for the most part, cluster them together into the categories. So recall the animals, then all the vegetables. In other words, by putting them together into the groups, by chunking them, by organizing them, by clustering them, then you recall more items, because the more clustering you have, the more items you're going to recall. Organization is a powerful way of organizing free recall, for example. So how we process at encoding determines how well we remember. Levels of processing and organization. We also have images. Imagery is a powerful task to help improve our memory. For example, we can show pairs of nouns, two nouns together, where you know later I'm going to present you one noun and you have to recall the other noun. That's sometimes called a paired associate task. I have pairs of words, and if I associate them together, I'll remember them better. And I have 2 instructions. I say, I want you just to repeat the word pairs over and over, sort of a maintenance rehearsal. Or the instruction might be to visualize the word pairs acting together. So if one of the words is bunny and the other is train, I might see a bunny sitting on top of a locomotive on the train, or I might see the bunny as the conductor of the train. I associate them together through imagery, through visual imagery. That's a kind of elaborative rehearsal. Then I'm going to show that that instruction, the visualization instruction, leads to much better recall than simply repeating the pairs. Because that's a maintenance rehearsal. It's not elaborative rehearsal. Elaborative rehearsal allows better memory. If you think about it, elaborative rehearsal is also what we see with depth of processing and organization. If we engage in adding information to what it is we're trying to remember, rather than just repeating it over and over again, it's going to lead to better memory. In fact, if you look at the actual levels of recall, with the maintenance rehearsal instructions, they recall 37% of the paired response. And when they used the imagery instructions, they had 87% remembered. So a huge difference because of not just using maintenance rehearsal, but of using elaborative rehearsal to remember the words. When you use some kind of task like this to help you remember, it's called a mnemonic task. And what I've just talked about are all mnemonics. A very common mnemonic is organization, or clustering. Try to group the ones together into bigger chunks. Unifying imagery, the imagery study I just showed you by Bauer and his associates is an example of a mnemonic device. In fact, imagery is a very powerful mnemonic device. But there's some others which you have to sort of learn. Georgia Tech students know the colors of the spectrum by remembering simply Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. The colors of the spectrum in order by just having that mnemonic word. Or 30 days, half September, April, June, and November. Another mnemonic for remembering how many days are in each month. By the way, you might be interested to know that that particular mnemonic device, 30 days, half, was found in a 15th century manuscript in the British Museum. So it's been around a long time to help us remember how many days are in a month. Another commonly used mnemonic is the peg word system. My wife says, I study memory, I don't do it, and that's probably true. But I do have a peg word mnemonic of 10 things. And so if I just have to remember 10 things, I can do it with that mnemonic, never forget anything. So I never write, if I only have 10 things to get at the grocery store, I never write a grocery list because I can use my peg word. 1 is a bun, 2 is a shoe, 3 is a tree, 4 is a door, 5 is a hive, 6 are sticks, 7 is 7, 8 is a gate, and so forth. And then I simply, when I said, okay, I need to get some cornflakes, 1 is a bun, I can see a hamburger bun filled with cornflakes. How crunchy it would be. It wouldn't taste like a hamburger, however. Then when I get to the grocery store, I say 1 is a bun, cornflakes. 2 is a shoe, milk. And I can remember my grocery list by simply using the peg word mnemonic. A famous mnemonic that's been used since the ancient Greeks is the method of loci. The Greek orators used to use that since they didn't have paper to write things on, to remember the points they wanted to make in their oratory, in their speech. And what they would do is walk along some familiar route, like from your house through your neighborhood, and they would place the points they wanted to make in their speech, or what I want to remember using this mnemonic, in places along the walk. So if I go out of my door, walk to the street, there's my mailbox. That's the first location, and I would simply put the first thing I want to remember in that location. I turn right and go to the next house, and they have a beautiful flower garden. I put the second thing I want to remember in the flower garden, and so forth. And then later, when I want to remember the information, I simply walk along that familiar route and look at the places where I want to remember, and there it is. It's sitting in that location, and I remember it. Very commonly used mnemonic device, the method of loci. An interesting, really good memory is one that called flashbulb memory. And it's where you remember very vividly something that happens to you in the past because it was unexpected and it was emotional in its nature. It's a vivid memory for unexpected and emotionally arousing events. These events have been different depending on what generation you're in. The attack on Pearl Harbor in the 40s did that. The Kennedy assassination was my flashbulb memory. I remember exactly what I was doing when I heard that Kennedy had been shot in Dallas. I happened to be in college. I was coming back from lunch. I know who I was with. I know what I did for the next day. I used to use this as an example of flashbulb memory in my memory class. And one time I was doing it, and the student raised their hand and said, "Dr. Smith, I wasn't born then, so I don't have a memory of it." And I said, "Well, I've got to learn to change my flashbulb memories." But we had recently the Challenger explosion, 9/11, at least for Americans, is a flashbulb memory. The cause of flashbulb memories are debated. Some people believe that flashbulb memories are actually a different kind of memory than other kinds of memory, but I think most memory psychologists believe that it's simply because of its emotional salience, because of its unexpected and its salience as an event in our lives, then we do remember information in detail. There's some debate about whether we have absolute accuracy. I will tell you what I was wearing. I went to a college that required you to wear a coat and tie, so I'm sure if I was coming back from lunch, I had a coat and tie on, but I don't really remember what I was wearing. I do remember who I was with, and where I found out exactly and what I was doing. But the level of detail is debated. In fact, that you retrieve this event many, many times. Was it remembering the retrieval of the event, or was it a memory for the actual event? So there's a debate about how accurate this detailed information is. Now I want to talk briefly about how things are forgotten from episodic memory. One is retroactive interference, where I learn list A, I learn list B, and then I recall list A, and the learning of list B sort of interferes with my ability to recall the early information. So things that happen during the retention interval interferes with my ability to remember the event earlier. That's called retroactive interference. Or I can have proactive interference. I learn list A, I learn list B, and then I recall list B. So something that I learned prior to learning list B interferes with my ability to learn list B. Interesting study that occurred by Endel Tulving at the University of Toronto. He actually found retrograde amnesia. Retrograde amnesia is something that happens, interferes with my ability to retrieve something earlier, in just a list of common words. He presented a list of common words, just frequent nouns. And in the middle of the list, he placed an unexpected famous name, like John Kennedy. You remember John Kennedy very well. The interesting thing is you don't remember the word that preceded that. Because you saw John Kennedy, an unexpected item in this list of common words, you don't remember the word before. You sort of stop the processing of that word. Some people call it the disruption of consolidation of that memory. And you don't remember the word before. Just like if something happened, I wouldn't be able to remember the event that occurred just before that. Retrograde amnesia. We'll talk a little bit more about that next time.